we did not allow that. That phase, energized phase, had to be covered in rubber, and you could not put that hook on the conductor itself. It had to be, you had to use like a tie sling or some kind of sling with the metal ends on it to clip back into that insulating stick.
So you had to use like a collar rope, or like the blue slings that we have?
Yes.
Okay. Blue sling, it had to have rubber on it.
Yep.
Blue sling around the rubber. This clipped into the blue rope.
Correct.
And then lifted up.
Right.
I agree 100%. That's what we had to do also.
You're going to close around it to grip it, hold it in place. And at this point, they will simply lower that pole into position using the boom truck and the digger derrick. You can also perhaps see, again, why we needed to create some separation in these lines. You see that line in the foreground being held in place by the jib, top of the screen. And then we're back at street level here as they guide the base of that pole. It's about a 45-foot new wooden pole, about 8 feet down into the ground.
Ooh, that's dusty.
Shovel in some soil that they dug out from there and use a tamping tool. That red tool you see in the foreground to tamp down the soil around the base of the pole. Next, you see the use of a plumb bob here to ensure vertical integrity of the pole. And as we pan back up on this newly installed wooden distribution pole, you can see the tool you see in the foreground to tamp down the soil around the base of the pole. Next, you see the use of a plumb bob here to ensure vertical integrity of the pole. And as
okay, Robbie, got a question for you on this also, because we had to change to this. We used to use a metal rope sling to set poles with, and then we had to go to a chain, and this chain is made for gripping poles. What did you guys have to do?
Same thing.
Same thing? All right. You had to go to chain, and you had to move away from metal rope. And to be honest with you, gentlemen, back in the early days, the rope that came from the line truck was steel cable. Obviously, that's changed out now to a nylon rope that's substantially bigger because of conductive properties. And there's another reason behind it, because linemen were noticing they were destroying something all the time with their rubber gloves. You know, wire rope has those little fine pieces that stick out that are very sharp that would puncture a rubber glove and you wouldn't even know it. So that's the reason why we went from metal slings to chains, is for rubber glove damage. And of course, this on the line truck, so we don't have a conductive wire coming from the boom all the way down.
as we pan back up on this newly installed wooden distribution pole, you can see to the bottom right corner of our screen, our line crew getting ready to move the energized lines onto this new pole. And here they are starting that line transfer on the first phase using the jib on the bucket truck. You can see the two other phases or lines here in the foreground being held out of the way.
You ain't got no
Now
shield.
let's go up into the bucket.
What was the question?
You ain't got no face shield.
They're not required. Who asked that?
Whittington.
Okay, yeah, they're not required yet. They're in the making, but face shields are not required.
Using our GoPros to watch the process. And you can see here that he's simply going to set this line into that insulator that's been put on the new pole on the cross arm. And then the other lineman will reach across and insert this pin or bolt to hold that line down into the insulator. And then tighten that up with a drill.
How about that for tying your wire in?
That's pretty neat.
They're pretty neat. They're pretty neat and grossly expensive.
Yeah.
Next, on this side of the cross arm, he's going to install a dead end.
You can actually hear it going on right there. That voltage is probably about 19 kV. One thing over here is there, in the area you need to work, say from here to probably about in there, you're going to need open space to be able to get conductors on, but there's no rubber here whatsoever. You want to listen closely.
They use a different bracket for that fiberglass cross arm, huh?
Yeah, it's all one piece. Doesn't even need braces. There's one bolt on top, one bolt on the bottom.
Yeah.
But you can hear the buzz as soon as he takes the dead end shoe and touches it to the primary.
Next, on this side of the cross arm, he's going to install a dead end.
Hear it? Beep, 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 beep.
Yep.
And if you heard that, as he connects with the line, you can hear that it is a live electric line. Now he's going to tighten down the shoe on the end of this dead end. And on the other side of the cross arm, he's going to install a clamp, also sometimes called a pork chop due to its shape. And he's also going to use a series of straps and a winch, also called a come-along, to tighten this line and also create a bubble over the top that they call a jumper over the top of this cross arm. You can clearly see that bubble or jumper being formed here. Good. And now we can move on and repeat the same process on the middle phase. You see they've taken the line guts off of it now to move it onto its insulator. Good. And now.
Okay, so it's kind of hard to tell what's going on back here. But guys, I'd probably scold a crew pretty bad if I went from this phase under it to the next center phase and they didn't put any rubber on it. I'd tell them to come down.
Yeah.
This is very dangerous. Now you're working with your shoulders and your head above two different phases. So you're gonna have phase-to-phase voltage going on and the potential for contact with your back or anything that goes on with another person if that bucket's at an angle. Now you're making contact to here, possibly. Rubber goods have to be on the phase behind you.
We can move on and repeat the same process on the middle phase. You see they've taken the line guts off of it now to move it onto its insulator. Yep.
Well, they do have a hose right there. It was right here, but I don't know how far it stretches out.
Yeah. All the time.
That's not enough.
Yeah.
No, you need at least 2 or 3.
The
now same process as the first phase. First install a shoe, then this.
Okay. Golly, I could tear this video apart.
That picture right there, Professor Shoemaker, with the blanket. Our rule was that if when you cover up on an arm, the phases going out, you probably had to have 3 to 5 hoses out each direction.
Mm-hmm.
Could not see any conductor, any kind of metal, any kind of hardware that you could come in contact with up under those blankets.
So you need to cover the insulator, you need to cover the wire, and you need to cover the whole dead end right here. Obviously, it's
right
behind the boom. We can't see it right now, but it needs total coverage.
Right.
There it is.
Yeah.
So
right
that's incorrect.
Right.
He's got one blanket. All you need to do is take another blanket and wrap this whole thing up.
Yeah.
And now
Watch his tightening method.
same process as the first phase. First install a shoe.
Okay, what's wrong?
He didn't crisscross and he
You-
ran it completely tight.
Right, you tighten it like a tire, side to side.
Then this, use a come along to tighten it. Again, you'll hear the electricity on the line.
Mm.
And once the middle phase is secure, they will start on the third phase, the roadside phase in this case. And so then here they are bringing that third phase over onto its insulator.
Again,
No cover.
I would probably put some cover over here too, even though I'm not working on this side of the pole, but this is required, guys.
Mm-hmm.
You got to put cover in these areas because you're on this side of the pole and working on it.
On the cross arm. And then this should look very familiar, using that come along once more to create a dead end on this third phase. Although nicely here, we get a great shot of that jumper across the cross arm. So as we return to street level and watch the line crew finish up this part of the project, you have now seen our T&D How video on an energized line transfer. Our participating utility was the Navapache Electric Cooperative. And this video was sponsored by Burns and McDonald. I am
Okay, that's it. What you put on, you take off in reverse. Of course, they didn't use that much, so it didn't take them a long time, which is bad. And I'll show you one of the comments. 25-year retired lineman here. Don't think I've ever seen so many safety violations on one job. Shame on the line foreman. Yep, if these boys were on the Duke system, they'd be fired. No cover in the arm or pole, boom under uncovered energized phases uncovered to their back, no positive control over the wire being moved. Does anybody know what that means?
Yep.
They're moving, when they got the wire that's suspended, they're moving the wire by hand. That is not positive control.
Right.
Positive control is when you hook it to the winch. Okay, so I'm going to stop share here. And Mr. Verm, any questions on the video?
I got one, Chief.
Sure.
What's the point of the jumper?
Electricity's got to flow through it.
I know, but why didn't they just have it on the bushings? Why did they tighten it up like that and make
That's going to be an engineering call in that situation. You have to have a double dead end. I think Robbie, if I remember correctly, every half mile.
Yeah.
Yeah. And the reason why you have to have a double dead end every half mile, one is if you need to do what they call manual isolation or, cut jumper isolation, or you don't want your wire, and I don't know what those insulators properties are. I've seen them before, but don't know how they work. You don't want your wire to slide. And you know what I mean by slide?
Yeah, moving back and forth from like the wind and everything?
Yeah, but if you've got, say, 10 spans on regular insulators and one phase burns down, it's going to slide through the insulators until it comes to one point, the dead end.
Mm-hmm.
So that's more of an engineer specified. Every so often, every so many spans, we're going to put a double dead end so our conductor will not fall to the ground all the way. If you went miles worth, then they would just keep sliding. Just the weight of the conductor would make it slide until all your conductor was on the dirt. Then instead of taking care of 10 poles or 5, whatever the case may be, you're going to have to take care of a mile's worth. Does that answer your question?
Yeah.
Okay, cool.
Okay.
All right, Professor V?
Yep. You guys ready to go over the test? Yep. All right, I'm going to go ahead and read these questions out to you, then I'll give you the answers, and we'll go from there. Just stop me if you got a question or want to make a comment. Somebody shout out the answer after I read the whole question and the options. What piece of equipment in a substation is used to measure current? Potential transformer, voltmeter, amp meter, current transformer.
Current transformer?
Transformer.
Current transformer, correct. All right, number 2. A fault is beyond a 2-count sectionalizer. A feeder, a feeder breaker will operate one time and the sectionalizer actuator will fire and open. True or false?
False.
False, that's correct. It has to operate twice. What piece of equipment in a substation, hang on, it's coming up, is used to measure voltage? Potential transformer, current transformer, voltmeter, amp meter.
Potential transformer.
Correct. Okay, next one. And I stands for what? Intermittent, instantaneous, or interval?
Instantaneous.
Instantaneous. Hold on a minute, guys. Let me get Levon in here.
Oh man, he showed up.
He's here. All right, so we said I was what?
Instantaneous.
Instantaneous. All right, question 5. A T operation stands for transient, total, timed, or test.
Time.
Yeah, that's correct. Overload is load beyond a specified value, a fault, fuse blowing, or fuse saving.
I put A.
A. Everybody got that?
A.
Load beyond a specific value.
Say it again, Jerry?
Load beyond a specific value.
Yes. All right. Number 7. Okay. A fault is low load value, high load value intense, medium load value a breaker operation.
High load value.
High load value. Number 8. True or false? An ACI has both I and T operations.
False.
False.
False. Number 9. When a fault occurs with a breaker, 1 phase opens, 2 phase opens, 3 phase opens.
3.
Phase.
Okay. Last one. Question 10. Which relay closes a breaker? The phase relay, ground relay, timed relay, or reclosing relay?
Recloser.
Reclosing.
Reclosing relay.
I got one wrong.
I don't remember what I put for ACI, but I think I got the rest of them right.
What was the ACI question, Professor V?
Number 8. An ACI has both I and T operations. True or false?
Yeah, and you know the reason why the ACI only has an instantaneous operation, correct? Who can tell me that?
Because it's got the solid bar that slams open.
What's it protecting? What's beyond the ACI downstream?
The old transformer.
There you go. Yeah, you don't want to put an extreme fault, well, when I say extreme, a timed fault inside the tank of a $2 million transformer. You want one instantaneous operation and open. Any other questions on the questions? Who had difficulty, Professor V, you did have a question in there about fuse saving, fuse blowing.
Okay.
That was the answers on the 2 count.
Yeah. Was that the 2 count?
Yeah.
Beyond the 2 count sectionalizer, the feeder breaker will operate on the sectionalizer. Actuator will fire and open.
Yeah, that's pretty obvious in the answer. It's a 2 count sectionalizer, and he said 1. So
Yeah.
it's got to go. It's got to count twice. Yeah. Okay.
I don't know why I mixed that one up.
That's okay. Take your time on the quizzes. And I mean, I had a couple students that one bounced me back about 4 o'clock yesterday afternoon, said, can you meet me on Zoom? If we're not in the room, you can text us. It had some questions about the questions. So if you want to improve your score, we're here.
Yep.
Okay. Any other questions on the quiz? All right, I'll go into one piece here, and then we'll take a little break. So I'm going to go back to share screen. So we're going to talk about here is really the brains that's going on as far as the systems that we're working with. And I know I've brought it up before, but we haven't given a definition to it, and it's called Scada. Got a little video for it here somewhere. Yep. And what you're looking at here is really a Scada control center. Now, control centers, Robbie, do you have one main one? Do you have multiple ones? What'd you have?
Multiple. Well, they were separate. Transmission has ECC, distribution has DCC. They're in two separate places in each state.
Mm-hmm.
And the ECC is almost like a fortress. I mean, if there's an emergency or an event or something, then they have big steel doors that close the entrances, and everybody's kind of sealed inside. So
yeah, we're in the same. Our DCC, which is Distribution Control Center, we have one, and it's on Highway 501, and right down from the college, right there. And our Energy Control Center, ECC, which takes care of generating stations and transmissions down in Muntz Corner. And agreed, both locations are under. It's really federal security.
Mm-hmm.
You're not allowed to go in or out of these control centers unless you have a swipe card and visual confirmation from a camera outside the door of who you are. What's going on here, gentlemen? And if you look at this one, Santee Cooper had their operations, this looks like the DCC center, had their operations split into 3 different areas. So there was Myrtle Beach and North Myrtle Beach were considered one area. Garden City and Conway were considered another area of operation in the SCADA Control Center. And Muntz Corner, their distribution was one. So you had actually 3 of these stations in a circle. And what you got an operator, sometimes 2, depending on how, if there's storms or what's going on down here. And what they're monitoring up here is just different substations, energy equipment that's out there on the system. They're able to open and close breakers. So that's everything that's pretty much going on. Now this looks more like a plant operation that's going on here, but they're monitoring and able to open and close breakers. And I'll give you the acronym here in just a minute. So, I mean, I've had a couple students that have gone on to this job. It does take a 2-year associate's degree minimum to get into something like this. And it's shift work. It's got to be manned 24/7. So it's 8 on, 16 off, unless there's a storm, of course. But it's just me. I'm a geek. I love going into the DCC Control Center and watching these guys work. It is quite. This is also where all of your radio communications are going on as far as your dispatchers are concerned. So.
I did some work in Scada in Pennsylvania.
Uh-huh.
Yeah, we had sensors in one of the reservoirs, so it would monitor. We installed all the sensors for the water levels.
Right.
And hooked up like 2 antennas that would relay it back to the control center.
Mm-hmm. Yeah, there are some, I mean, kind of minimalistic SCADA control centers, which are monitoring only. Do you guys remember the little lift station we had when we did the underground walkthrough over there at the college?
The turd chopper?
Yep, that's the one. They had that pole with the antenna on it, and that antenna was pointing towards their control center for Grand Strand Water and Sewer. Now they call it more like a dumb terminal. All that thing did was it sends a signal to their control center to say that the motors aren't chopping. So the thing won't overflow. So they dispatch somebody to it. They don't have any control of anything that's going on in there as far as sending a signal back to it. But it's just more of an alarm, a remote alarm system that sends a signal via radio. So let's watch this video. Kind of give you an outline of what's going on with Scada. Now this is probably not, it's not going to be in a utility situation. They did have utility videos out here on the internet as far as SCADA was concerned. The federal government asked them to take them all down. Why do you think?
Breach of security.
Yeah, breach of security. And we're talking terrorist stuff here now. There was certain things that you can observe and certain things that you could see that essentially you could take down a whole electrical system with a click of a couple mouse clicks. In 1998, and that's why companies are getting away from the radio aspect of it. In 1998, they did have a gentleman down in Tallahassee, Florida, that intercepted the signal going to a substation, wrote his own software for it, and was able to open and close breakers from his house, a private customer. Yeah, that's pretty bad.
The Scada acronym stands for Supervisory Control and Data Acquisition.
You're going to need to know that. What does SCADA stand for? I'm recording also, guys, just to let you know, so this will be on later on.
When considering this term, you can conjure images.
Say again?
I'm still writing it down.
Okay.
Yeah, give me just a sec.
Sure. And it's just like it says, I can supervisor and control, and I can acquire data. Let me know when you guys are good to go.
I'm good.
That's one.
Nope.
I got it.
Okay, here we go.
And you should. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos.
I don't know if I love
This way, you never miss another one. A Scada system is a collection of both software and hardware components that allow supervision and control of plants, both locally and remotely.
Okay, it's computerized. You've got hardware components that could be SCADA controlled or monitored. The part he's kind of leaving out is you got to have communications. All right, it's either by networking, fiber networking out in the field, or by radio.
Scada system is a collection of both software and hardware components that allow supervision and control of plants, both locally and remotely. The Scada also examines, collects, and processes data in real time. Human-machine interface, or HMI software, facilitates interaction with field devices such as pumps, valves, motors, sensors, etc. Also within the Scada software is the ability to log data for historical purposes. The structural design of a standard Scada system starts with remote terminal units, or RTUs, and
Okay, so an RTU, there is an RTU in every single substation we have. So the remote terminal unit is the interface between the equipment and the software.
or programmable logic controllers, or PLCs.
You really don't need to know the PLC. RTU, remote terminal unit.
As you know, RTUs and PLCs are microprocessors that communicate and interact with field devices such as valves, pumps, and HMIs. That communication data is routed from the processors to the Scada computers, where the software interprets and displays the data, allowing for operators to analyze and react to system events. Before Scada, plant personnel had to monitor and control industrial processes via selector switches, push buttons, and dials for analog signals. This meant that plants had to maintain personnel on site during production in order to control the processes. As manufacturing grew and sites became more remote in nature, relays and timers were used to assist in the supervision and control of processes. With these devices employed, fewer plant personnel were required to be on site in order to oversee and control operations. While relays and timers did provide some level of automation, the panels required for these devices took up valuable real estate. Troubleshooting was a nightmare, and reconfiguring was difficult at best. These issues, in conjunction with the need to grow even larger industrial plants, helped to facilitate the birth of automation. As you may know from previous videos, controlling industrial plants via processors became a reality in the 1950s. Gas and oil, utilities, and manufacturing were major users of these new technologies and supervisory control. About a decade later, telemetry came on the scene to offer even more remote capabilities, with automated communication and data transmission to remote monitoring locations. Another decade later, the term Scada was used to describe systems with PLCs and microprocessors that were being used for the monitoring and control of automated processes on an even greater scale than ever before. Scada, back then, was anything but practical. They were colossal machines, mainframes really, and since networking was not yet in the picture, they were standalone units. In the next couple of decades, the 80s and 90s, with computer systems getting smaller, the advent of local area networking or LAN and HMI software, Scada systems were able to connect to related systems. Unfortunately though, the communications were typically proprietary, which meant that connections outside of the particular vendor of the Scada system were not allowed. This early Scada was coined distributed Scada systems. Later in the 90s and 2000s, Scada began to implement open system architectures with communication protocols that were not vendor specific. As you can imagine, this opened up Scada's ability to connect with varying vendors. This newer, more improved Scada was then called a networked Scada system. Newer and improved Scada unfortunately didn't last long. With computer technology growing rapidly, IT development quickly gathered steam. The default database for IT became Structured Query Language, or SQL databases. Scada developers didn't implement these standard databases, so Scada became out of date rather quickly when other technologies so rapidly changed. Current-day Scada systems have adapted to the changing technologies and have a great advantage over the older Scada systems. With the adoption of modern IT standards such as SQL and web-based applications, today's Scada allows for real-time plant information to be accessed from anywhere around the world.
Okay, so just think of this, and I know it's in a plant situation, is he's got multiple pieces of equipment going on here. His RTU, and his RTU is connecting to a radio, and he's just transmitting it either by radio, or you can do this by fiber. These are essentially just substations. You're able to monitor your regulators and your breakers and your the position of your ACI and the temperature. Whatever point that you want to put into a substation to monitor can now, in the 2000s, interface with the RTU and then go over on Scada. So you have the ability to monitor everything. And this is great for forecasting what your future is going to be like. Do I need to add another substation because one's getting overloaded so much? And you're able to control. He's able to send signals back to the substation to control any points that he has set up for Scada to be able to be operated.
Having this data at the operator's fingertips facilitates improved plant operations, allowing for responses to Scada system cues based on field-collected data and system analysis. These operator interactions can be from a computer right on the plant floor to an office building in some other region in the world. Advancing technologies have indeed made the world seem like a very small place, relatively speaking. And because the current Scada system software has typically adopted the SQL database model, historical collection of data may be logged and used in trending applications to further improve plant processes, as well as creating mandated record keeping for some of the industries out there. Essentially, Scada is a collection of hardware and software components. This collection of components begins with real-time data collected from plant floor devices such as pumps, valves, and transmitters. These components don't have to be from a particular vendor. They just need to have a communication protocol that the processor can utilize. Data collected from the field devices is then passed to the processors, such as PLCs. From the processor, the data is distributed to a system of network devices. These devices may be HMIs, end-user computers, and servers. On the HMI and end-user computer, graphical representations of the operations exist for operator interactions, such as running pumps and opening valves. This data may also be analyzed and used to enhance plant production and troubleshoot problems. Want to learn PLC programming?
Okay, no. Well, unless you want to become an engineer, you don't need to learn PLC programming. So do you get the idea of how Scada works and what it's doing out there in the world as far as the utility is concerned?
Yeah, it's a real-time control center.
Yeah, exactly. And I'll tell you, shoot, I went to work at I started working in 1978. Scada didn't come to us till right around 1995, 1996, before we started implementing Scada. And then it morphed as it went along. So if you needed a hotline work permit in a substation on a breaker, what did you need to do?
Had to make phone calls.
No, you had to drive to it. I mean, yeah, there's no reason calling anybody.
I figured you'd be calling somebody at the substation and then
There's
they'd do it
nobody at
manually.
substations. Substations are unmanned. Safety Cooper has 148 substations on its entire system, ain't a soul at any of them. So you had to get in your truck. You had to go to the substation. You had to. This is the old days, Robbie. You actually took the reclosing relay out of the breaker. If you took the relay out of the breaker, of course, there's no reclosing. You just completely disconnected it. You put it inside the cabinet and drove on. You had to drive back. Then when you were finished with your hotline work permit, you had to drive back to the substation and put it back in. If for any reason, remember, the reclosing relay on that is for the entire circuit. So if you had a squirrel get on the circuit, even, and cause a fault anywhere on it, for one thing, the dispatchers didn't know you didn't have any Scada. The breaker would open, and the dispatcher just start getting phone calls, and more phone calls, and more phone calls, till they eventually called you and said, "Hey, man, do you have a hotline work permit, or do you have the recloser off on this circuit?" You say, "Yeah." So you got to run all the way back to the substation, close the breaker, take the reclosing relay and put it back in, find out what the problem was. You get the concept going on here. It was just, it was a pure headache as far as the employee was concerned, because he's traveling all over the planet having to do stuff, whereas now it's all automated. And that's just one example. Robbie, were you back in the times of no automation? I'm sure.
Yeah, it was, all those mechanical relays and the sub, like you said, yeah.
Yeah. So, it was kind of tough. So nowadays, and, really you as a new employee and all of the employees as far as the line field right now have that option of really getting real-time data as far as what's going on. It's like I told you yesterday. The dispatcher calls you out and says, today, well, you've got a breaker locked out at Surfside Substation. Now there's questions you can ask him, and he can give you information in real time. Did it go through all its operations, the I and 2 T's? He's able to see that because it was communicated back to the control center. And he's actually able to tell. There's one instance in Myrtle Beach, and I'll show you this, and then we'll take a break. Let me get back to maps. Ask y'all a question. If you have a major storm outage what's the first thing you need to get back on? Say you got like a system-wide hurricane that comes along. What's the first thing you need to power get back onto?
Hospitals.
Nope.
Feeder lines?
No. No, the major customer you need to get power back to.
911 center?
Nope. And think of today, most of those places are geared to have generation, and, you know, their own generator or whatnot. It's going to be industrial.
Water plant?
There you go. Water and sewer.
Water and sewer doesn't have their own gas turbines in the event of an emergency?
Nope. Right?
Yeah, that thing's right by my house and it stinks.
It stinks.
I can smell it. I'm down on 29th and I can smell it. And it's
Yeah.
like springtime. Springtime is pretty bad. It comes all the way down by me.
Well, there's the collection pond. And if you, I mean, surprisingly, you can drive right in here. They don't check for people. And they have sprayers that spray the little nice aroma spray over the top of it. There you can see the water part. And there's the feces part.
Good old Dookie line.
Yeah. There's really, I mean, as far as generation, to be able to pick all the pumps and motors back up in here, they'd have to spend an astronomical amount of money to be able to have that backup generation. They do have, and I'll show it to you right here on the map. This is a backup generator right here for electrical only. They're able to get power back on in their buildings, but it's not big enough to pick up a pump. And you'll see there's the generator with the, it's a cat. And there's the exhaust and there's the control room for it. Right here is a substation that has both a 12 kV input from this substation right here. So I have a 12 kV feed, the normal 34 kV feed, 34 is more reliable, comes all the way from here and goes back down 501 and comes over here to the Myrtle Beach 115, a dedicated circuit. One circuit comes out of here and is dedicated. No other attachments to it, all the way to Grand Strand Water and Sewer. The nice thing about this right here, gentlemen, and the substation does have battery backup. If I lose the 34 kV line, sorry, I can't drive in here. They don't have driving in this. There's two set of switches. There's one actually that you can see right here that's a recloser. I can open this recloser and close a switch right here and actually feed this substation automated. The dispatchers are going to get a signal. We've lost the 34 kV line going to Grand Strand Water and Sewer. They're going to send an open signal to this switch. They're going to send a closed signal to this switch. The substation's back in service. Nobody even had to go to it. Now they'll send somebody, if that happened and I got called out, they're going to do all that manually. And somebody's going to have to go back out there and just confirm everything's going okay. How long was Grand Strand without water? I mean, without power?
30 seconds.
Yeah, yeah. No more than 1 or 2 minutes. You don't want the candy water to back up. That's for sure. Okay. All right, gentlemen, it is 9:59. Let's say 10:10. We'll come back. So you're looking right, it's right down in the heart. It's the middle of Myrtle Beach, right down in there. And it used to be, back in the day, the only line, and it still exists, goes right by us at 501 at the college, was a 34 kV line, came from Conway, went all the way into the center in the heart of Myrtle Beach. And this was the only substation for Myrtle Beach. It's called Oil Plant Substation. And that fed all of what, you know, the whole 1,000 people of Myrtle Beach back in the day. They called it oil plant because if you lost the 34 kV line coming from Conway, they had an oil generator sitting right here. Here's the actual collection. That's where the oil tank sat. So in case you had a leak, it got collected in this bay. And they fire up the generator, and they'd run their own little generating station here to be able to keep power on to the beach. And that's back in the old days.
Good old days.
No, I hear you. Okay, so it is 10:14. We're going to go ahead and resume. I'm just going to stay on the share right here. So we talked a bit yesterday about relays and relay units, and Professor Vermelin did bring up the new technology that's coming along today, and that is what they call a TPU or a DPU, and I don't like these tabs being up here. Substation 2, there you go.
SEL.
So the old days, you go up to a breaker panel, or they have, sometimes if you have big stations, you have a breaker house. And these are the old electromechanical relays. And if you had, so you had phase relays, and these are stacked up and down instead of side to side. You had phase relays, so you're able to get information off these relays just by looking at them. Like I said, electromechanical. They do have a little window in them, and they have an I and a T target, so you can see what kind of operations that you had. And if you need to disable a relay, there's got some knobs on it right here. You just pulled the cover off and pulled the relay out. That's not a very smart thing to do. Once you remove an electromechanical relay, do you have any open protection on a phase relay? So we'll say this is A phase. If I take the relay completely out and I have a fault on A phase, is there anything to recognize it?
No.
No. But reclosing relays pretty much came in and out in the old days before Scada pretty often. They didn't even have a switch where you can turn it off at. If you had a reclosing relay, you take the knobs off, take the relay completely out, and so you don't have reclosing anymore. This is still in existence. I'd say Santee Cooper, if I were to give a close estimate here, is probably 80-20, 20 being the old and 80 being the new. Robbie, if you had to take a guesstimate, what would you think?
Oh, Duke, it's when I left, probably all our subs had converted over to the SEL relays, and I think there was still some substation relays that still had the old electromechanical relays.
Right. So now the new technology is all those boxes, those black boxes, was an individual relay. Everything now is in what they call an SEL. So it's a Schweitzer electronic control. Schweitzer electric is what that's for. And the different model numbers are going on with it. So the three letters that you need to know as far as these are concerned, this is the new and going to, is TPU, Transmission Protection Unit. Protection Unit. Boy, I got dyslexia today. And DPU, Distribution Protection Unit. Okay. And they pretty much look almost exactly the same, don't they?
Yeah.
Yeah. A lot of information going on here. You're not going to ever interface with it as far as electrically. This is all going to the RTU. So you have information from the RTU, that's the Scada interface. But it will give you a lot of information as far as, and capabilities as far as the pad and the control panel. Obviously, if you want to manually open or close the breaker, what do?
Hit the buttons.
Hit the shiny red
Press some buttons.
Okay. There are some special features going on here as far as safety. If you have an emergency and you need to run into a substation, and what they're going to have here is this is going to be in a panel, and they're going to have over the top labeling that says breaker A, breaker B, breaker C inside the substation, so you know which one to identify. It does scroll on the screen, but you want to be able to identify quickly. For safety reasons, if you go straight in and do nothing else, you're able to open a breaker. If I ran in immediately and did nothing as far as SCADA or this panel, you're not able to close it. Can you understand the safety reasons why?
Yeah, because you're not looking to see if there's any kind of fault. You're just closing it.
Right, you don't know what kind of faults that you have on the line. You're really not 100% sure yet if you have anybody working on the line. You don't know if that line has been recorded or reported somewhere else, that the line might be down on the ground. The only capability that you have here right now as we speak is open, and that's for safety reasons. There are two modes that go on here as far as the DPU or TPU are concerned. Local and remote. In remote operation, SCADA controlled. And I'm going to put over here, you can open only. That's a safety feature. That's the only thing that you can do when it's in remote. You can open the breaker up. In local, do anything. All right, when I say do anything, you can do anything with the control, but it is still SCADA monitored. Essentially, you put this thing into local, you've taken away control from your dispatchers in your control center, and you can do things on the panel that you need to do. But SCADA, the guys in the dispatch center, are still able to see what's happening. In remote, you can open only. Now, it looks kind of daunting when you look at this thing, doesn't it?
Yeah.
All right. It's not that bad. It's just going to give you readings. This all down in here is more technical in the situation, but it's going to give you readings, and this display is meant to give you priority of readings. The priority when it sits there just in normal operations is IA, IB, IC, and IG. Well, what is IA? What's it? What the reading am I looking at right here?
Amps for that phase.
Amps for the phase and amps for ground. We'll talk about amps for ground later on. So that's what it's going to be sitting on most of the time, and these numbers are just going to be going up and down with the amount of amps. If this thing operates and goes to lockout, it will actually show you on the screen lockout, and it'll show you the reason why. C fault, or B fault, or C, B, and A fault, or ground fault, whatever the case may be. All right, over here, this is the part, you look at it right here. If you want to take control of it, you're going to press this button and the light's going to go off. It's in local right now. If you press the button and the light comes on, then SCADA has control of it. All right, how do I get a hotline work permit on this control? I have to do it manually.
Hotline tag button?
Yeah, what two things do I need to do and take into account right now? This remote enabled light is on.
You can call it dispatcher.
Let's not use SCADA control here. Okay, I've got remote enabled on.
Turn it off and then
All right,
hit the
turn it
hotline
off.
tag.
Remember, the only thing I can do when it's in remote, SCADA controlled, is trip it open. You've got to take local control. So you got to press this button, the light turns off, then do what?
Hotline tag.
Press that button, you'll get a light here and it'll show in the window. Hotline tag. Okay? As far as that in this control, and as far as you guys are concerned, that's as far as you need to go with it. If you want to get more technical later on, if you want to be an engineer, or if you want to work in substation maintenance and relay, you will learn more about it. But as far as alignment is concerned, and not to say, Robbie, you could probably give some testimony to this. How reliable was the Duke SCADA system as far as communicating with your substations and use?
It was fairly reliable. Well, it was really reliable in the bigger places, but like at my sub, that's because I was at the tail end of the line for the system. That always seemed to be an issue, you know, for a while, was communications, and I'd have to actually go to the sub and, you know, operate the breaker, or, you know, put it remote or local or whatever. But for the most part, it was good, but down here it seemed to be an issue.
Okay. We worked at, I know of 2 instances that were, one was actually, we had a server failure at the control center, and we lost, and this is back in the early 90s. We had a server failure, and we lost Scada completely.
Yeah.
That happened during the daytime, so everybody knew about it. It really wasn't a huge concern. All the stuff we had to do was manually. But then that night we had a thunderstorm, and we lost about 6 breakers in the area, and you pretty much had to do everything manually. We didn't do anything more than what we're looking at right here. Either trip open or get hotline tags and go from remote to local. That's what
I got a question, Chief.
Sure.
Would you turn off the recloser if you were
That
doing?
does that. The hotline tag does that.
Okay, so you don't have to hit that button; it does it on its own.
You're correct. Yeah, this is really a lot of digital stuff is going on in here. So as soon as you hit the hotline tag, and to be honest with you, where are the 5 relays at?
Down below the alt type, maybe.
Anybody else? It's all in this box. Everything's in here. I've got 3-phase relays, and they're not electromechanical, they're digital now. I've got the 3 relays, the 4, IA, IB, IC, and IG, and the reclosing relay are all encased in this box. So as soon as I hit a hotline tag, it disables the reclosing relay from this box. Does that answer your question?
Yes, sir.
Okay. This is one they added on later in the future. For anybody, and I kind of laugh at this part of it. We had guys that were going into substations, the communication guys, and really not substation people, that for some reason we started getting these units, started using them, and all of a sudden you get the call on the radio, and we'll say this is Singleton Ridge A. Singleton Ridge A just went to lockout, and or just opened. So we'd ride out there, patrol it, ride back to the substations, and you see some, either somebody cleaning it or something like that. And what they did is, well, yeah, I accidentally leaned up against this thing and it tripped open. Which was kind of, a head scratcher in the process. So they added this one down here at the bottom. And what does it say?
Lock.
Yeah, everything on this control panel, the trip still works. Everything on this control panel is locked until you hold and press that for 3 seconds. Then you're able to do whatever you need to do as far as these controls are concerned. You can get some other kind of cool data out of it. Is it working? Is it enabled?
Mm-hmm.
Yep.
Okay. Is it in lockout right now?
Yep.
Yeah, it's in lockout. What kind of trip targets? Did you have a trip?
No.
No. Was it an instantaneous trip?
No.
Yeah. Do you have communications? No.
No.
No. So there's other stuff that you can look in here. But as far as we're concerned, know what you need to do to be able to, 1, get a hotline tag on it, trip it open. Now you as beginning lineman will never get the instruction to close one. They're going to either send somebody to you or they're going to get SCADA control back to close one. That's a safety feature as far as companies are concerned. They don't want you ever closing a breaker. Any questions?
Now, if your trip light is on, is it going to show down in the fault type? Like if line C was the one that had caused the trip, or
so if you've got trip here, right? If you got trip, it's going to scroll through whatever problem you had up here at the top.
will it also show it down at the fault type box?
Fault type box.
Yep. Go down, down,
Yeah,
down. That one.
It'll show you the phase.
Okay.
So if you have a fault on A phase, it's going to show you trip. A is going to light up.
Okay.
All right. Surprisingly, yes, there is a ground fault and there is a neutral fault that doesn't exist on a system that comes on later on in the course. Okay. Okay. Any other questions as far as the DPU or TPU? TPUs look almost similar, the same. The nice thing, and you guys that are talking about going into transmission, we did institute this on the transmission side of these relays is, and I'll jump back real quick so we can get another familiarity of how they work. So I've got, let's see, size. Oh, I'm unable to do it on this screen. Okay, stop share. Share screen of screen 2. Share. Okay, you should have my writing board, right?
Yep.
All right. Is remember in transmission, and use this when you have the capability to use it. We started enjoying it very much. Is if I've got a, dang it. If I've got a transmission substation, I'm just going to draw a breaker on one side, and the breaker's on this side of it, and I've got a ton of line that comes down here. I'm drawing from a distance. Sorry for the squiggly stuff. And I've got another substation down here, and another breaker on this side. So I've got full line protection. The TPU on both sides, and this is due to mostly transmission lines, although not straight, don't tap a lot. Is this one, we record the velocity, and this one, we record the velocity in time of the fault, and actually that information goes back to the Energy Control Center via Scada, and they got it down to about 75 to 100 feet. We'll be able to tell you where the fault's at, location-wise.
That's pretty cool.
It is pretty cool, and I can tell you one thing, it is extremely helpful when you're looking at transmission lines that span from Winyaw to Conway. I mean, you can imagine trying to patrol that entire area, whereas they can tell you it takes about 15 minutes for them to get all that calculated out. Is they're able to tell you, you need to go to structure 5, 6, 7, 8, 9, pull it up on a map. That's where the fault occurred within 100 feet direction both ways. It is pretty cool. And I have to admit, I was kind of skeptical about it. I used it about probably a dozen times. They were not wrong any of those times.
Right.
Okay, stop share on that one. So, all right, so we know what kind of equipment we're using. We know how Scada works. Scada sending information back and forth, and we're able to control stuff. How is the equipment that we're using? I lost all the pictures that I had before. Okay, how is the equipment that we're using, and we're going to use this breaker for an example. I have a distribution breaker also. What two pieces of equipment are we using to meter or measure, transform amperage and voltage down to where it could be used in this control panel? And we talked about this yesterday. We'll say, because this is just single conductor, 900 amps flowing through this side of the breaker, 900 amps flowing back out of the other side of the breaker.
Are you screen sharing?
Huh?
Are you screen sharing?
I am not. Sorry. Thank you very much for the information. I am now. Let me know when you got it.
Got it.
Okay. So I've got a transmission breaker here. Single conductor in, so we'll typically say right around 900 amps. 900 amps in, 900 amps out. I can't take 900 amps in my control panel right here and be able to meter or measure it. It's just way too high. So what am I using to convert that 900 amps down to something that's usable in electronics?
The metering current transformer.
Current transformer. All right. Where's it at?
You got me on that one, Chief.
Are the bushings?
Top? Bottom?
Bottom?
Right. There you go. You look at these things, right? This is the current transformer. This is where it sits and resides on here. And you see these rings like this on any piece of equipment. You are metering and converting current. Now you have one on the inbound and one on the outbound. And you can actually see the wiring harness that comes off here, and it's going down to the control panel for this one phase, phase A, phase B, phase C. All right, it's going into the control panel. Now he said RTU or PLC interface. Like I said before, we usually use RTUs. So I'm able to come in here and get actual readings in here if I need to. I'm able to open and close the breaker from here also. But what's going down here? If I could interface here locally, where do I need to get all this the same information to?
To Scada?
To Scada, exactly. So this is all the wiring that's going to Scada and the RTU that's out somewhere in the substation to be able to communicate. So I've got two modes here. And usually what's inside here is this is transmission. There's going to be a TPU in this box that you're able to control, but it's also interfacing with Scada underground. So, you know, multiple parts going on here. There's my CTs. Conversion of high amperage down to low amperage to use in the TPU. I can control it manually in this side of this box. Once I take local control, usually stays in remote, and that interface is going down through here underground to either a radio tower or a fiber optic interface.
Now, if you switch this thing to local, can Scada still take back over control and turn it back to remote?
Not until you, great question. Not until you give it back to remote. So let me get back to the,
So you have to manually transition it back.
once I have unlocked it, now they know I've done it. Once I have unlocked it, press and hold for 3 seconds. This is already in local because I have no light. Say it's lit up, I press it, they're gonna get an alarm in the dispatch center. It's gonna say Surfside A is now in local. When I say alarm, it's alarms would be going off all day long, wouldn't they? It's just a ding ding. And it's gonna prompt them on their screens. Remember that control center that I showed you? It's gonna prompt them on their screens, Surfside A is now in local. All right, obviously, if it happens and you have not contacted the dispatch center, they're gonna have some questions, or they're gonna start calling somebody, hey, Surfside A just went to local. You're gonna have to communicate with the dispatch center before you do anything on this. All right. Communication, even though you put it in local, communications is still happening with the dispatch center. If that gives you any inclination of what's going on there. It even knows if you unlocked it. Okay? All right, so I had a picture of it on substation breaker. I don't like the way this tab sits up here. We had that. All right. So in the substation transformer, images, I'll give you see if I can find a decent one going on here. Let's go this. All right, so the substation transformer, now we're going to have that capability on a transformer also, correct?
Yeah.
Okay, so this is kind of, it's all right. Lightning arresters here. That's the high side bushing of the transformer. That's the incoming voltage. And then transformed, and here's my outgoing voltage. You can see that the bushings are much smaller from high to low, so I know it's a substation transformer. Another set of lightning arresters on this side, and then back out to the bus. Although it can't be seen, the CT and the PT transformer for converting amperage down to a readable level and voltage down to a readable level are encased in the transformer. So they're not showing like the rings that you had on the breaker. So I have a CT, on this side and a CT on this side and a PT on this side and a PT on this side inside the tank of the transformer. What does a CT stand for?
Current transformer.
Current transformer. What does a PT stand for?
Potential.
Potential.
Potential transformer. Now, the typical mode of operation here is I've got a CT here and a CT here that measures current, and if I've got any incorrect current flow, what am I going to trip open over here? What comes before the transformer, protective device?
Right.
ACI. We're on the transmission side. All right. The PT is here, and there's one other location we need to look out for. If there's any indifference in voltage that doesn't calculate correct with the transformer, it's going to trip the ACI open, and control minus. Now, they don't show it in this picture. I'm going to put PT transformers at the end of the bus work that's inside the substation. So if I have any difference in voltage between the bus and the end of the, the transformer and the end of the bus, I'm also going to trip the ACI open there. Why do I not put current transformers at the end of the bus?
Doesn't it use a different material for the bus network?
No, it's not that. PTs I will put at the end of the bus. Let me find you another picture here. Hold on, guys. Give you something a little bit better to look at. Stand by. This will work. Oh, excellent. Okay. Wow, this is odd. No, that'll work. So I have inbound voltage, and actually this is going to, part of it's going to be going underground. I'm going to put, the output of my transformer come down. I'm going to here at the end of the bus, and I'm going to put a PT. So PT here, and PT here, all measuring differences in voltage. I've got a CT on the inbound and outbound of the transformer, so it's monitoring the amperage in the transformer, but I don't put a CT at the end of the bus.
Because there's no change in the current?
Right, but where can I get a current reading from that encompasses the whole bus?
The inbound.
After I go through the bus, where do I go to? A breaker, and the breaker goes out to the feeder, correct? Am I getting an amp reading per phase on the breaker?
Yeah.
You are. So what's going on in this process right here? If I have 4 breakers here, and let's say I've got 200 amps, 200 amps, 200 amps on all 4, which equals 800. Those CTs are going to give an 800 measurement for all 4 breakers. I should have how many amps on the outbound of the transformer?
800.
800. There you go. It's comparing my CT reading from the transformer to all the breakers that are connected to it. If the 800 equals 800, everything's copacetic. And my 800 in conversion in the transformer is equaling what it should be on the high side. Everything's fine and dandy. If this is sending out, if this is measuring 800, and for some reason this one goes to 2000, what's the ACI going to do?
A trip.
It's going to trip the ACI. I don't have a feeder problem, right?
Something in the buswork.
Something in the buswork. Now you have electrically protected both voltage and amperage. Somewhere inside the station, I've got a fault. So that's the reason why we put them at those locations. Okay. It's 10:44. Let's take about 10 minutes and we will come back. Screen one. Share. All right. Know what a TPU and a DPU are. Transmission protection unit, distribution protection unit. Know what local and remote is, as far as you going into a substation and having to do anything. And I know some of you are probably saying, wow, it seems pretty advanced for me to have to go in a substation and start working something electronically. Especially during storm situations and you're working for an organization or company, they know you're young. Well, I mean, you might not be young in age, but they know that you're new and you're going into a situation that you're not familiar with. As far as our dispatchers were concerned, and I like the way they did this here. When you go into a substation and you say, they're going to tell you, we'll go to Surfside Breaker A, and this can be over typically radio or phone. Don't worry if you don't sound like you know everything that's going on in there. And I can guarantee you, when the DPUs and TPU units came on into Santee Cooper, most of the line crews were dumb to what they could do. And you could get on a radio, even supervisors and area operations supervisors. So if you go into a substation and you open the door to Surfside Breaker A and you're looking at this DPU unit and there's you saying, what do I need to do? And that's exactly the question you need to ask. They, on the other side, are going to ask you, what's the unit number? And you say a SEL 3351, whatever it is. They're able to bring up a picture on their screen of the actual unit, and it shows all the instructions underneath it. Now, they're pretty versed in it, but they will actually talk you through the steps of what you need to do. So you don't need to know this by heart or anything like that, and they will talk you through it. You'd be amazed about how much time savings you can have, how much safety awareness is going on in these situations when you're doing something like this, and how much power you can restore as an employee in a quick amount of time if you just know some of these basic features that we're talking about in the classroom. I'll give Whittington here as an example. Whittington might go to work for Duke Energy, and he might not have this situation happen for 1-2 years. He might not ever have to go in a substation. It's that one time that you walk into a substation. He might have to go in the first week. Who knows? It's that one time that you walk into that substation and you're not having to stand there and have yourself fit. We'll go to breaker A. They're all labeled. Well, now you know what a breaker looks like. All right. You open the panel door and you know what to look for, either electromechanical relays or a DPU. You look at the DPU and it's lit up with lockout. You know what lockout means. So you see the path that we're going here. You're able to relay information back to them where they can relay information back to you. And I mean, to be totally honest, does it make you look good?
Heck yeah.
Heck yeah, man. Guys, I think of this. If I hired John Doe, who was a landscaper off the street, and the dispatchers called him and say, hey, John, I need you to go to Surfside Substation and take a look at breaker A for me. For one thing, he probably wouldn't know what a substation was. Then he wouldn't know what a breaker was. If he did get that far, you open the door and then he just wouldn't know what to look for. You guys now, through education and superior knowledge of your professors, of course, know what to do. Okay, so I'm checking on Robbie. He's making phone calls for that sling. So at any time, if you have questions and you're working on something in a substation in those situations, feel free to make contact with your dispatchers. The dispatch, I don't want to put this poorly, don't rely on your supervisor or your fellow co-workers if you're in there alone. If you're in there as a pair and you both know, call the dispatchers, call your control center, because eventually who has control of it anyway?
The operations center.
The operations control center. Okay. So do follow this. Okay. Hotline work permits. That's a must. You need to know what a hotline work permit or tag is and how to obtain one in a substation. How do you do that?
You got to start by calling the dispatcher, right?
You can call the dispatcher and have it done by Scada.
You hit the hotline button on the panel.
You skipped a step, buddy.
You can go through Scada and get a hotline work permit, and that's just a procedural communications. I'd like to get a hotline work permit on breaker A at Surfside. They're going to call you back to reconfirm. You're going to say that's correct. Okay, they're going to do it all by Scada. You don't have to go and do anything. All right, there's going to be some responsibilities here. You must stay in radio communications. So you must have a radio with you at all times. Why is that?
That way they know when they can open it back, well, close it back up.
It never is closed. It never is open. A hotline work permit just disables the reclosing relay.
If there was a problem, they could open the relay?
It's going to open anyway by itself, but you're tracking correctly. If there's any problem.
So they know you didn't fry yourself?
That's one. Okay, so you got your hotline work permit. You're working through the course. And remember this, gentlemen, if you're working at a specific location, the hotline work permit, and this is imperative, is for the entire circuit, not just the location that you're working at. So if you're working on, I'll say it again, Surfside A, and that's a mile-long circuit with 200 taps on it, all of that is under the non-reclosing protection. It's all under the hotline work permit. So if a fault occurs, it may not be at your location. The dispatcher will call you. For one, he's going to get a Scada indication that the breaker is bad. Sure. He's going to get an indication that the breaker opened. And two, the phone's going to start ringing off the hook as far as trouble calls. People are going to be without power. Who's he calling?
You.
You. Yeah. You're the man on the circuit. Okay. I've heard this go on, and it doesn't disturb me as far as anger. I start feeling bad in the gut. When a crew is sitting out there, it's got a hotline work permit, the breaker opens because it's on non-reclosing, and the dispatcher is going, 260, this is division.
260 is a limp man on a pole.
Well, 260, that was my number. And I've got the hotline work permit. 260, this is division. And he's just going to keep doing it. All right. He's going to get another dispatcher over there, and he's going to start calling your cell phone. 260, this is division. And you can see I'm riding around. I'm thinking about, the line crew had a hotline work permit. By about 2 or 3 minutes, if he's not answering, I'm thinking somebody's hurt. Okay. So after that, after about we went by the standard of 3 minutes. After more than 3 minutes, they're going to start calling 911. And 911 is going to respond to the location where you were working at. That's where you asked for the hotline work permit to start with. All you had to do was answer back if it wasn't you and say, hey, we are in the clear. Did not cause the fault. Close the breaker back. So somewhere on the line, a squirrel got on it, or whatever. Tree limb fell into it. You weren't even at that location. All right, you got to stay in that communication for you to relay the information back, because a dispatcher or controller will never reclose a breaker without recommunicating with you, the holder of the hotline work permit. So there is responsibility here. What employees can get a hotline work permit?
Probably just the foreman's.
Anybody else?
I guess anyone.
Everybody. You walk out the first day on the job, you're the fresh new guy that's filling up water coolers, you can get a hotline work permit. All right, that's a safety feature of organizations. If you see something going on, you might not be even working on it. A cross arm broke and a phase fell close down to the road and you think it's dangerous. You do one of two things. Call Scada and say, I need this line de-energized. Just give them a pole number or look close to that location. Or you can get a hotline work permit immediately. So that's a safety feature of all companies. But there's responsibilities that follow. You must stay in radio communications when you do have it. I've had too many employees where I felt that were responsible. Yeah, go ahead. If you need a hotline work permit, you can call for it, you can get it. That eventually, something happened and they're unable to get them through radio communications. All right. There's another reason why you're going to be using radio communications in this process. Why can't I just use the phone all the time?
Because you're not going to have it on you while you're up in the bucket.
That's one reason.
You could lose service.
That's another good, decent reason. The big thing here is where you try to stay away from the phone as much as you can as far as communications are concerned with your controller, is nobody else can hear you. Right? Everybody else on the system, once they hear that breaker locked out, they're going to perk their ears up and they're going to start paying attention to what the conversation is about. If we don't hear anything, if communications is going on in the background we don't hear about, then you might be missing some information that's going on in the process. So try to stay away from that. There's also another reason here, and this, please keep this in mind, all dispatcher communications is recorded. Every phone call that's inbound or outbound from the dispatch center and every radio conversation in and out of the dispatch center is recording, and that's a federal law. So be careful of what you say, and that must be maintained for 3 years. Okay, so do remember that. Getting kind of off subject here. If a dispatcher calls you and calls you out to work from his phone, and they call you from the dispatch center, and you've had a couple beers, what are you going to say on the phone?
I'm not coming.
Yeah, I'm unable to come in. Remember, whatever you say is what?
So don't say I'm trashed. I can't come into work.
No, sir. Because if I go back and you've done that multiple times, and I come back and I say, and anybody can request them in the company, hey man, do you have the recording for the phone call you had with Whittington the other day? Why I didn't come in? He says, yeah, sure. I'll queue it up for you, send it to you in an email. Well, I can't come in because I'm trashed, or no, you don't want to say that on a phone. Just say I'm unable to come in at this time. Right? Don't make a habit of that. Mr. Robbie, are you back? Not be still on the phone. Okay, so these pieces and components that you're seeing as far as a substation, SCADA control, relays and whatnot, that's really the big everything in a nutshell that that you need as far as your work is concerned as a new lineman. A lot of it just boils down to and relates to safety. Safety is the major thing. Now, we spoke about it the other day, and I didn't have very many questions on it. I was kind of perplexed. Do you need to get a hotline work permit when you're working on a tap line?
Yes,
And why?
because the line is still energized unless you open the fuse.
Okay, so in this is plenty of years ago, the assumption was if I was working on a tap line, I didn't need to get a hotline work permit because the fuse would blow. So
Yeah, but if somebody else comes along and sees an open fuse and just closes it and you're down the line and they don't know, now you're a dead man.
what's that got to do with a hotline work permit?
Well, the hotline work permit lets everybody know because the dispatcher knows, right?
Well, the dispatcher's going to know if the fuse blows too. I see where you're headed, and you're definitely hitting right all around it right here. I need more a technical answer.
Not sure how to put it, Chief.
Okay, you're hitting all around it, and you got some great answers that are going on out here. The breaker is faster than the fuse. Okay, breaker technology nowadays. B-R-E-A-K-A-E-R. Yeah, right. Breaker is faster than the fuse. So the breaker, I target or I operation is how fast?
It's like 1/20th, right?
3 to 5 cycles, or 1/20th of a second. Okay. Fuses, especially in a fuse, which scheme?
Blowing.
Fuses in a fuse blowing scheme are going to take sometimes, I mean, you might not think of it, half a second to 3/4 of a second.
Big difference when you talk about exposure.
Yeah, exactly. So that exposure, the voltage, that is something that is going to kill you anyway. If there's an electrical travel through your body. But if you can limit this exposure to the arc flash and the flame to 1/20 of a second instead of half to 3/4, guys, that's monumental as far as the damage that's going to either happen to the equipment or the pole or to you. So that's why we get hotline work permits on tap lines. All right, I want to jump back to here, and Professor V spoke about this yesterday. We actually found something on our system. On the 34 kV on the Santee Cooper system, 34 only, we use a fuse blowing scheme. So what's the first breaker operation, I or T?
T.
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 So it was timed. Guess what we were doing? And I brought up, just by chance, it didn't happen due to an accident or anything like that. I brought up to our planners and controllers, when we get a hotline work permit on a 34 breaker, what really happens? And you know what their answer was?
That's not good.
That's not good. You get one-timed operation. That is extremely bad. Okay? Instead of 3-timed, which they had it set to, you get 1-timed. So I went back to our engineers and I said, you need to reconfigure so that when you go to a hotline work permit, I get 1 what?
Instantaneous.
I get 1 I only. That actually took a good bit of work. Relays had to be changed out. Configurations had to be changed. But that'll give you an idea of how those things work as far as INTs. We were kind of shaking in our boots about this one.
Yeah, that's full exposure for 1 cycle.
Yeah, it's full of, sometimes for multiple cycles. I mean, we had been getting hotline work permits on 34 kV for years.
Thought you were covered.
And we thought we were covered. When actually, instead of 3 times, they said, yeah, you've got 1-time target. No. I want 1 instantaneous only when I get a hotline work permit on a circuit. All right. The other part of this one, we've talked overhead so far here. Do I need to get a hotline work permit when I'm working underground? Rob, you're going to need to help me here.
Okay.
I'd say yes. Still a line.
There's one yes, and I'll take votes on this.
I
Robbie,
mean,
Sir.
would you?
overhead or underground, still a line, right?
All right, think of it this way, and think of it the way we've been working out here in the field. As soon as I leave the switch and go from that termination through my underground primaries, is there any exposure to a live underground line?
Mm-hmm.
Yeah.
There's live underground primary on my site. Exposed. And when I say take the
might have
word,
misheard you. Say it again.
is there, when I'm working with my underground primary through my our underground URD site, is there any exposed live, think of it as a live situation, underground component while I'm working on it?
No, just in the enclosure.
Yeah, just in the enclosure.
What live part do you see in the enclosure that is exposed? I can physically touch it.
The feed-through.
Elbow?
The what?
The elbow?
I have to manually stick something down inside the elbow to touch something that's energized.
Right.
So that's not truly exposed. What else?
The panel that's in there?
You're talking about the four-way module?
Yeah.
I'm going to have to take clothes hanger or something like that and stick it down in the insert for me to be exposed. That's covered also. And to be honest with you guys, I'm not saying you're right or wrong. This is out for debate.
Yeah.
This is a big debate between utilities. I'm glad I'm discussing it with you guys.
Right.
The neutral?
The neutral's not energized.
Wow.
All right. When you move elbows around, and I know I helped you guys because one, you're new, and two, I know it's de-energized. What are you using?
Shotgun stick?
The shotgun stick. So actually you're away from it, and now you're using a 100 kV per foot stick.
Right.
So back to the question. Do you need a hotline work permit while working on URD?
No.
Not by the book?
When you say not by the book, it depends whose book it is, right, Robbie?
That's right. Exactly.
So Santee Cooper, then, now, and at this time, does not require that you get a hotline work permit while you're working URD primary energized. All right, with non-exposure. There are some pieces of equipment that are out there that have exposed primary parts. Hotline work permit is required. But for all of their new equipment, they're not requiring it. All right. You go inside a transformer or cabinet where you actually need to get up close to it. You might need to put a blanket down and manually handle it. You're going to have to get a hotline work permit. But if I need to pull an elbow off a transformer or put it on a parking stand or put it on a feed through or do something of that nature, we do not require a hotline work permit because really there's no exposure to it. Robbie, what do they do it do?
Same thing. Anything like that inside a pad or anything, no hotline work permit. The only time we do it if it goes from overhead to underground or reverse dip and it's or a riser pole and there's no switch up there and you have to go up there and mess with it hot.
Right. Okay.
Well, couldn't you argue that if you have to take the elbow off by the shotgun stick, that, I mean, there's still a possibility of danger there? So, I mean, it's not like you can reach in there with your hand and grab the elbow and pull it off.
No. If you can do all work with stick work, and that's where I kind of bounced back to it before. And I'll give you some true life examples. You go in there with a shotgun stick, and this is a good one, and you need to put it on a feed through to change the transformer out. You put your feed through in with a stick, you pull one elbow off, you put it on the feed through, you pull your other elbow off, put it on the feed through. You take the feed through off the transformer with a stick, no hotline work permit required. All right, here's the bad scenario. You pull the elbow off and the tip that's inside the elbow that goes in the transformer stays lodged in the transformer. Yeah, that's happened more than once. All right, you need to get that tip out of the transformer, right? is it now an exposed part?
Yeah.
Yes.
Right. Are you going to call for a hotline work permit?
No.
Yes.
We did. As soon as you had a live exposed part, and that was one of our rules, anything that was exposed, you had to get a hotline work permit. Now, obviously, you can pull off the other elbow and you won't have that feed anymore. But the rule was for us, once you have a live exposed part out there in an underground situation, you needed to go ahead and get a hotline work permit. And it might be just for short duration. You might just need it for 10 minutes to get everything square. But that was our rule. Robbie, I heard you say no.
No, they didn't make us do that.
Yeah.
No.
Yeah. I think it's more in the concept of all-encompassing.
Right.
Yeah. The rule came to us was anytime that you had a piece of metal, something exposed on the primary side in an underground situation, you had to get a hotline work permit.
Right.
Okay. Wow. Gone through a lot today, haven't we? Let me make sure. That one's been done. That one's been done. We traveled to Myrtle Beach for a little bit. That's a good indication right there, a control panel of DPU and TPU unit combined. You can combine these units. The switches and controls that you see down here at the bottom, you can actually disable the units through this method, pull one out, put one back in. Breaker, distribution breaker. All right, let's see if you remember this. What does red mean?
Live.
Hot. What does green mean?
Open.
Open. Thank you. Thank you. All right, we talked about this one. We talked about this one. And that's my remind text service. Wow, we're at 11:21. Okay. So, how's everybody doing on their presentations?
I sent mine in.
Okay.
Hopefully I have mine finished up this afternoon.
Okay. It's just open for questions. If anybody has any questions, we can answer them now, both Robbie and I, as far as those presentations are concerned. Okay.
I sent out a couple reminders to guys. There's a couple of you missed the quiz yesterday. I opened it back up till I think 11:30 tonight. So go ahead and take that quiz for yesterday.
Yeah. While you're talking about that, Professor V, you know, it is really nice to see, and you guys interacting with us, getting on with us every morning and getting things done. Now's the time to ask questions if you got questions. If something comes up later on the day, by all means, feel free to text us. Well, we're great to do that. But we'll give you this information as a whole. We're finished with the underground portion. And we had some missed quizzes where I texted those students back and said, well, I'm going to reopen it for you. And had plenty of zeros.
Mm-hmm.
A 0 and 100 equals a what?
Yeah, 50.
50.
Zero.
That's still an F, you know. So you guys are doing good and you're paying attention and getting your stuff done. Most of it's communication here. Appreciate it. Doing a great job. But there are some out there, and I hope you're listening to this conversation, that if you're missing a test and in the course, you just said there's some missing now, Robbie, in this one?
Yeah, 2.
Yeah, there's 2 missing in this one. Now, you got the text to take the test, and if you go back and the test is not available, text us and we'll open it up during the course. But once the course is over, it's over.
You slip it.
Yeah?
Someone's slipping.
Yeah, yeah. So, you know, I've seen some 55s, some 56s. Everybody can see their, oh, I do have to quote on that part. Everybody can see their test score from behind. You pretty much know what your grade is right now. If you got a 0, you don't want to add a 0 on top of that. So,
and I've published your grades this morning, so the ones that's taking it, you can go in and see what you did on it.
Yeah. Robbie and I are pretty flexible here. If you made a pretty poor score and you ask us if you can retake it or if you need some assistance, we'll help you out.
Yep.
Yeah. we typically don't turn 90s into 100s. They're both A's. But if you're down there in the, I think your lowest one was what, Robbie?
50.
50, yeah. That's going to need a lot of help to get up to a C. Remember, I'll say this, emphasize, a D does not pass a course. And one course not passed in the entire scope of courses does not get a certificate. So you're shooting yourself in the foot out there as far as that is concerned. You guys remember the underground equipment list I had? Kind of extensive, took some time, where you had to list all the pieces and parts to equipment.
Yeah.
Okay. That, for some reason, I cannot grade. It is bombed in D2L for me. So guess what everybody got on that one?
100?
100. 100, and I can't even put that grade to it because it bombed out. So I don't know if you did the work or not. Everybody just got 100 on it. That's a freebie.
Sweet.
Okay. So I think I gave my daddy conversation there. You know, you get online, people get a little bit slack. Things kind of get missed by some people, not all people. Once again, some of you guys are really good at this. So that's it for that. All right. This will be recorded. I will post the recording today. There was a specific reason why I didn't post the recording yesterday early. It is on today for yesterday's stuff, just to see what would happen, and what happened did happen. So that will be on this afternoon. Tomorrow, 8 a.m., plenty of water, your dirty clothes, all your climbing gear, including boots, and we're going to strip down the yard tomorrow. There will be no D2L and no online class. We'll be in the field from 8 until 12 tomorrow, 11:30, 12 tomorrow. Robbie, are you quizzing today?
I'd just say let's go. Let the ones that didn't take the test take the quiz, retake it, and if you want to retake it, look at your grade and open it back up for another attempt for you.
Sounds like a plan. So finishing up your presentations, they got to be in by 12 tomorrow.
Yep.
Yesterday's quiz retakers, contact Robbie or contact me on D2L.
Yep.
All right. Any questions from anybody else out there?
I completely missed it. Do we have a quiz today?
No.
No, sir.
All right.
Okay.
I got a chain. I'm gonna pick it up this afternoon.
Oh, fantastic.
But if our stuff's due tomorrow, that means tonight you got to finish your presentation because we'll be in the field.
Yes, sir.
Yep.
Yes, sir. All right. Any other questions?
Since my email's been being weird, could you see if you got my presentation whenever you got a chance?
Yeah, hang around with me when we're done with this. All right. Anybody else? All right, guys. Go ahead.
I was just going to say that Wilson, if you need to send it to me again, I can forward it on for you again, man.
All right. Yeah, I think I figured it out, but we'll see.
All right.
Hey, Robbie.
Here.
How is he able to send it to him and not to me? What's going on?
What's going on with that?
That's what I was saying. I thought you had me blocked or something. I don't know.
No, I haven't got you blocked, but we'll double check it as soon as we get done here. Okay. Any other questions? Feel free to ask now. It's going to be hot tomorrow morning, so be prepared for that. And my expectation is the 4 lines that we used for testing and training, those are going to come down. If he's got the chain, we'll start working on the taking some poles out, pulling some poles. We'll use the line truck to take down all the transformers. So we're going to have some line truck operators and use the Mini X to haul stuff around. So yeah, be doing some work tomorrow. Okay, with that, I'll go ahead and close. Gentlemen, have a good, safe day.
You too.
Take care.